And now we are going to discuss the solubility and the solvent's routes interaction. Like we have the lithium chloride, we are dissolving it in water. So, as I discussed you earlier, just before, that lithium chloride is an ionic compound, can better be dissolved in water. But this lithium chloride, it won't be dissolved in gasoline because this is the polar solvent, this is not the polar solvent. Similarly, these both are insoluble, non-polar solvents and solute. They can easily dissolve, uh, like gasoline can better be dissolved in a benzene. But lithium chloride, being a polar ionic compound, cannot be dissolved in benzene. So this again shows uh, that the like dissolves like. It follows the like dissolve like the principle for dissolving substances in this particular solvent. Now, this is though not it is a rough rule, we can say, but can be used to predict about the solubility of certain solutes. Clear? Okay. Now, dissolving ionic compounds. How does an ionic compound like sodium chloride, lithium chloride, etc., can be dissolved in a polar solvent? Ionic compound can be dissolved in polar solvent like what? Polar solvent like what? Like H2O. Clear? Is when we are putting sodium chloride in water, sodium chloride or lithium chloride in water, an ionic compound in water. So what happens? That they are losing their crystalline form due to the fact that we say that water is a polar solvent having the two poles, the negative and the positive pole. Clear? Once it is attracted by another oxygen. Clear? Once we are putting the an ionic compound, one of them, so what happens, the negative end of the water molecules and the positive end of the ionic compounds, they are attracting each other. There starts an interaction between the two and splitting the ionic compounds, are distorting their crystalline form. So each positive ion, like the lithium, is surrounded by attracted more towards oxygen part, which is the negative one, and hydrogen is the positive one. Similarly, oxygen is attracted towards the positive lithium of another molecule, and this is how. And similarly, the negative end of this ionic compound, the negative ion, on the another hand, is attracted. Like they both have the chloride in common in them, so the chloride is attracted by the positive hydrogen of the water molecule. Clear? Of the water molecule. The negative end is attracted toward the positive hydrogen part or end of the water molecule is attracted towards the chloride, and this is how the sodium chloride or any other ionic compound is fixed. This process, when an ionic compound is splitting or losing its crystallinity inside the water, and this is how they are dissolved. This process is called solvation. This process is called what? Hydration. Hydration, when for hydration it is necessary that the solvent must be water. Similarly, dissolving ionic compound in the non-polar. Similarly, if we dissolve the non ionic compound in a non-polar solvent, what could be that? That could be benzene or carbon tetrachloride, CCl4. Okay, there. So there will be a very less or no effect of both solvent and solute upon each other, like the way they dissolve the water, dissolve the ionic compound, or the polar solvent dissolve the ionic compound. There will be no or very less interaction between the non-polar solvent and ionic compound, so it won't dissolve each other. Similarly, okay, now and the liquid solvent solute solvent interaction, we need to know about the two terms. This is called the miscibility of a liquid solute and a liquid solvent. Then simply, when we are talking about the two substances which are in solvent state and they are in liquid state, and we want to dissolve it in each other, if it get dissolved, so they are called miscible, and if they won't dissolve in each other so freely, they are called immiscible. Clear? The two liquids which are soluble in each other, which can be freely dissolved in each other, that is called miscible, solvent and solute. And those which are not, like for example, benzene cannot be dissolved in water. So now we will say, as both are liquid, so we will say that benzene is immiscible in water, but benzene is miscible in carbon tetrachloride because they can be dissolved in each other. Like benzene can be dissolved in this solvent and cannot be dissolved in water. Clear? So miscibility and immiscibility, this could be clear to you now. We have now another ethanol and water. Ethanol has the general formula C2H5OH is ethanol. Clear? It is ethanol. The formula, and the water, they both have common the OH. Clear? And when the oxygen, when a hydrogen is bonded covalently with fluorine, oxygen and nitrogen, any of these three, then such a bond, such a molecule can make an interaction with the other molecule of its own kind, which is called what is called hydrogen bonding. So there is the common thing in these two, ethanol or ethyl alcohol and water, is the hydrogen bonding. Let me once again define the hydrogen bonding, though you have already done it in your bonding chapter, but let me explain. If the hydrogen in a molecule is covalently bonded with the fluorine, oxygen and nitrogen, any of these three, then the oxygen or the negative part of one molecule will be slightly attracted towards the positive uh, part of another molecule. Both are water, you can see both are water, but its negative is attracted toward its positive. So such a bond is called hydrogen bonding. So when you are putting, you have a water solvent, clear, and you are dissolving ethanol and add, they will be completely miscible in each other because of one thing in common, which is hydrogen bonding. Clear? So this is ethanol. This is also called ethanol water system. Okay. Similarly, what is the effect of another final things effect we are going to discuss is the effect of the pressure and the solubility. Effect of pressure and the solubility. Effect of pressure. So I can very easily make it clear to you through a very simple daily life example. Like we have the fizzy bottles. When we are releasing escape from it, clear, the fizzy bottle like Coca-Cola, Pepsi, when you are releasing what escape, you see that the bubbles of gases, they are fizzing out very quickly from it. Clear? This is because of the fact that the solubility depends of gases. The solubility of gases depends on what? On the temperature. At very low temperature, the gases are soluble. At very low temperature, I am repeating it again. At very low temperature, the gases are more soluble in liquid. And one thing, and secondly, at very high pressure, the gases, they are soluble. And the examples are the fizzy bottles, are the cola drinks. When you are releasing escape, you are putting it in a colder part of the fridge. So what will happen? These gases will remain soluble, and when you are releasing the cap, releasing the pressure, what happens? The gases, they are fizz out. Another example I can give you of that at very high temperature, when the temperature is very high, so the dissolved oxygen inside the water, inside the lake, it happens what to it? This dissolved oxygen is decreased inside them due to high temperature. So what we call the biological oxygen demand, which is necessary for what? For the living organism, aquatic life over here, that is decreased due to the high temperature, and it would affect. But if the temperature is low, the oxygen will remain dissolved inside these lakes. Okay, thank you so much and take care.